things that are special. So let's go through this. It is 2 samples, but it's done in a weird way. It's not hard at all. The calculator does all the thinking for us. We just got to make sure we put things in the correct way so we know the answer. And as we go through matched pairs, keep in mind that the way I show you in the notes is one of 2 ways you can do it. Not that the other way is any harder or easier. It's just you can think of it from one direction to the other or in reverse. So the tricky part of this will be to make sure you're paying attention to which direction you've chosen so that your hypothesis tests are being written down in the correct way, because otherwise you'll have them flipped and then you'll get some weird funky numbers and make a wrong decision just by accident. So we'll talk about that when we get there. But as we're going through this, you just have to kind of pick a decision or pick a direction and then kind of just go with it. All right, so matched pairs. You may or may not remember way back in October. I mean, this feels like a year and 6,000 months ago. We talked about matched pairs as a way to run an experiment in Unit 3. And there were 2 different ways we can do matched pairs. They're sitting there in your notes, Form 1 and Form 2. So let's review this real quick just so that you are somewhat familiar with what the heck we're talking about. So the one way to do a matched pairs experiment is to take a group of individuals, so a group of 2, right? Therefore the name pair, that have similar or certain characteristics. So maybe all tall, weird-looking teachers like Mr. G would be paired together, or whatever, right? So you're gonna find a characteristic that's similar that you're testing, and you're gonna put people together in groups of 2. You might remember the slide. We had all the smiley faces and the frowning faces, and some were green and some were red, and I went, and they all paired up. That's what I'm talking about. And then you randomly select treatment for A, and then the other person gets B. All right, so that would be a matched pairs experiment. In this particular version of the matched pairs experiment, here's the important part. Assignment B is dependent on assignment A, meaning when you randomly select somebody to get the first treatment, letter A, the person who's going to get B is the leftover one. So they're dependent on who randomly gets picked for letter A. But it's highlighted there because it's important. The important word here is it's dependent. Okay, we've been talking about independent stuff quite a bit. So we're looking at something now that's dependent. So we got to change our thinking just a little bit. Version number 2 is where we don't match up people, we match up treatments or experiments. And so we just take one individual person, all right? So maybe I'm sitting at a grocery store or something, and I just happen to see somebody walking by, and I'm like, hey, you, sir, tell me which soda you like better. They're going to randomly get one of the treatments first, tell me their opinion, and then they're going to randomly get the second or 2. So they're going to do both treatments. So now the treatments are assigned as a pair versus the person. So that's the second version of this. But again, the 2 measures are dependent on something. In this case, they're dependent on the person that walks by. So I'm no longer controlling the characteristics of the individual. That's completely random now. So whatever their characteristics are going to cause some sort of dependency in my treatment. So if I'm testing like a new soda drink, what their preference is going to cause them to like or dislike something, A versus B, Pepsi versus Coke, whatever kind of taste test we're doing. So this is just a review or a reminder of what the heck matched pairs are. We talked about them in, like, say, eons ago in October, which was like a whole different world back then. And or at least it feels that way to me. I don't know about you guys. But we had 2 different versions of matched pairs. So this is an experimental type of treatment. So this is why we're talking about dependent assignments, because we're actually assigning some sort of treatment to people, or something is already going on and we're recording the results. So let's go through some of these examples and see, would this qualify as a matched pair? Because if it's not, then maybe we use one of our other tests that we've already talked about. But if it is, then we can use this matched paired one. And think about those 2 things I just told you. Either we got to have a group of 2, right? A partnership of 2 where the treatment B is dependent on A, or we got one person doing 2 different treatments. All right, a college wants to see if there is a difference in the time it took last year's class to find a job after graduation and the time it took the class from 5 years ago to find work after graduation. Researchers take a random sample from both classes and measure the number of days between graduation and first day of employment. So the answer for this one is no, because we're not pairing individuals up on similar characteristics. There's nothing here they have in common. So we have 2 completely independent samples. The graduation class of 2000 is completely different and independent of graduation class of 2005. All right, yes, they're going to the same university, but we all know that the job market changes and the type of degree they have and all that stuff is so completely different from each of the groups there's no similar characteristics there. So this would not be a group of 2 doing the same treatments or one person doing both treatments in a random order. So just put down on number 1 that no, this would be 2 independent samples. Therefore, this would not count as matched pairs. Matched pairs, again, it's one of those kind of weird, often not used type of experiments. So we want to be able to identify it as we go through. All right, let's go to the next one. In a taste test, a researcher asked people in a random sample to taste a certain brand of spring water and rate it. Another random sample of people was asked to taste a different brand of water and rate it. The researcher wants to compare these samples. This is almost matched pairs, but there's a problem here. They don't have the same individual doing both water, different types of water. And so if they had had that happen, this would have been matched pairs. If you had the same people test both brands, because what happens here is if I get like this class and I just split it in half and one half does treatment A and the other half does treatment B, I don't know if the characteristics of people in treatment A caused that to be why they liked the first one versus people in treatment B having their characteristics. So with the taste test, it has to be the same individual or it's an irrelevant taste test. All right, so almost. Well, I bet you the next one's going to be it, right? Because we only got 3 on here and one of them has to be the example. So see how this works. All right, so number 3, a pharmaceutical company wants to test new weight loss drug. Before giving the drug to a random sample, company researchers take a weight measurement on each person. After a month using the drug, each person's weight is measured again. Aha, 2 measurements, same person, we're good to go. These are dependent on some sort of characteristic that we can trace it back to. So in this case, this is dependent on the individual. So if Mr. G does this experiment, my initial weight is going to cause my second weight measurement to be whatever it is. It's dependent on what my first one is. And same for everybody else who's going to do this test. So there's a certain dependency in this experiment. That's why it's highlighted in red there on your screen again. Something has to be dependent on something for matched pairs to be considered to be the type of experiment. So I lost my phrase there, sorry guys. So in your notes, they have it highlighted there in form 1 and form 2, the dependent part. If you want to make sure you put a little star next to that or say, this is why I'm looking for matched pairs because there's some sort of dependency here. Then number 3 is your example of matched pairs. Any questions so far? I know it's kind of weird early in the morning, but we're just kind of looking at what would a matched pairs example kind of be. Hope looks really excited. If you guys can see her, she's just like, she can't wait to do this. How's it going, Miss Hope? Did you enjoy your, oh no, you had the SAT test on. How'd that go? Felt like you understood everything on there? I kind of peeked at the math. I'm not supposed to talk about this. I kind of peeked at the math and it looked like if you had paid attention at all in the last like 6 years of life, you should have been okay. You upstairs, G Hall? Yeah, I may have been like carrying the, I was probably carrying like the bucket or something. Yeah. So I went over there to go help, right? That's the team. We were there to assist, and I found out my guy ruptured his Achilles tendon, so I just pretty much did it. Like I walk in the room, he's like, "Hey, I can't move anywhere." He's got like this big wheelie chair. Misha, he's your algebra 2 teacher. I forget his name. Anyway, he's a nice guy, but he's just like, "Yeah, I ruptured my Achilles tendon playing basketball," and he was feeling pretty depressed about it. So I was like, "Yeah, no problem, man. I'll help you." All right. Let's do example 1 together. So again, if you got your calculator, get it ready. We're going to type in a bunch of stuff into the list here. And I know it's your guys' favorite part. First thing in the morning is to start doing computer calculations, but here we go. A whale-watching company noticed that many customers wanted to know whether it was better to book an excursion in the morning or the afternoon. Hey man, when are the whales eating? To test this question, the company collected the following data on 15 randomly selected days over the past month. So the days are not necessarily consecutive, and we're going to say that this is matched pairs because the morning and afternoon is dependent on which day, right? So it's going to be like one day is getting 2 treatments, a morning and an afternoon. So they're not randomly taking different mornings and different afternoons. It's the same morning and the same afternoon on the same day. So grab your calculator, go to stat, go to edit, and then we got some lists. Let me split screen this baby so you guys can see what's going on. That one goes there. This one gets out of my way. All right, so that one goes in. All right, so I'm gonna use 3 different lists here. I'm gonna use list 1 and list 2 to type in what I see for morning and afternoon. So you don't need to worry about the day number. That's just telling you what day it is. We know we got 15 entries, but for morning, I'm gonna put in 8, 9, 7, 9, 10, 13, etc. And for the afternoon, I'm gonna put in 8, 10, 9, 8, 9, 11, etc. Okay, so do that first. Yeah, I got to do it with you because they erased mine, but I don't have to do it fifth and sixth grade. Yeah, it's weird being back over in that place again. I realized how small the classrooms are. At least it feels that way to me. Yeah, especially the one I was in. Like I looked around, he had. I mean, it's probably because he had like 30 desks crammed in there stuff, like which is weird to me. Like we were told specifically not to have more than like 20 in this room for social distancing, so I can spread out. But like every kid in there is like this, and there's like 30 of them. I'm like, so this would make sense why all the COVID alerts were going off in fall because nobody was separated. Anyways, so. All right, everybody got your lists? But I mean, I guess they don't have the space over there. It's just weird. All right, so list one, list two, I have morning and I have afternoon. All right, so remember what I kind of said at the beginning. We're going to see this here in just a minute. You have a choice on which direction you want to go. I'm going to pick a particular direction here in a second. You'll know what I mean when I show you. So if you just want to follow along with me and make that your direction, that's fine. If you want to try it the other way, you can do it too, because there's two different ways we can look at this as we go through the matched pairs problem here. So we have two values for each day, therefore they are dependent on the day. So this is why this qualifies as a matched pairs example. So going looking back at it, 1, 2, and 3 on the previous page that we looked at, this is dependent on what day I pick. So if I pick August 15th or whatever, then I have a morning and an afternoon. They're both dependent on that day. So the same day is getting two treatments, basically, a morning and an afternoon reading. So this is matched pairs because of that, not like the graduation one where it's 5 years separated or anything crazy that way. All right, sorry. First, you must find the differences for each day. So if you remember, the whole point of this unit number, what are we on, 7, once we've gotten to all this two sample stuff, the whole point is measuring the differences between the two. And that's what this question is asking us. Is there a difference between the morning and the afternoon so that we can tell customers, yeah, if you want to see more whaleys, then come out in the afternoon or morning or whatever we find is the differences. So that's what we're looking for in this one. So in order to do that, we're going to have to do some subtraction in the calculator, and it's going to help us do it. So you may subtract, this is where you can go either direction, morning minus afternoon or afternoon minus morning. Which way is better, Mr. G? There's not really a better way. It's just your preference. All right, so I'm going to do the morning numbers minus the afternoon numbers. Okay, so you don't type these numbers into your calculator. You're going to use the formula part. So go up to list number 3 and make sure you highlight the top part of it. This is a review from stuff we did way back in the fall. We can hit the second button, and then morning is our L1, so we'll hit L1 minus, and then hit the second button again, and afternoon is our L2. So you should have this at the top of your thing here. L3 is L1 minus L2. So I'm taking away my morning minus my afternoon. That's the way I'm going to go. So 8 minus 8 should be 0. 9 minus 10 should be -1, et cetera, et cetera. Okay, so you can go the other way if you want to. There's nothing wrong with doing afternoon minus morning. All of your numbers will just have the opposite sign on it. So what I have is negative, you'd have positive, and vice versa. Okay, but we're still going to have the same differences, if that makes sense. So again, is there a better way to go? No, I just went top to bottom. All right, so we're measuring the differences. So this L3 is what we're going to focus on. Is there enough of a change between L1 and L2 to say, yes, one of them is better or worse than the other one, so that when customers call, we can say, yeah, you need to book in the morning if you can, if you want to see more whales or whatever. All right, so again, I subtracted morning minus afternoon. You could subtract the other way. This is completely your choice. We need to do our test now and set up our hypothesis test by stating our assumptions and what kind of test we're doing and all that. So the space that you have on your notes underneath your little chart there, this is what we're going to do. We're going to name the test, talk about the assumptions, prove that it's normal, random, all that stuff, write the hypothesis the correct way, do the calculations, and then make our conclusion. So we're actually running a hypothesis test over the differences on this. So this is where you got to be careful. Which way did you go is which way you have to state your null and your alternative when we get to that point. So let's start with the assumptions and the name of the test first. This is a one sample t-test match pairs. And the reason why it's one sample, even though we're looking at two samples, a morning and an afternoon, is because we're just focusing on the differences. So this is why match pairs is a little different. The same two assumptions need to be met like all other means. We need to make sure that it's random and that it's normal. So we can say we have a simple random sample of days for whale watching, check. So random because, there's the first one. And then we need to say, since the probability plot is approximately linear, the distribution of the differences is approximately normal. So we have to go back to the graphing option, and I'll show you guys where to find this in the calculator again to prove that we have a normal-ish set of data here. Because we don't have a word problem that told us everything's approximately normal. Because you wouldn't know that if you work at this whale company anyways. Like these guys that are doing this aren't going to be like, well, yeah, I've kept data for 15 years and it makes this normal curve. Like this is more of a real life scenario where you just got a bunch of data in front of you and you're trying to find things out. So in your calculator, you're going to want to hit the second button and the y equals button to bring up our stat plots. You might remember this from a little bit earlier in the semester here. Press number 1, we got to turn it on because it's usually off. And then the graph that we want is the very last one, way over here on the right side. This is our normal probability plot that'll tell us if it's linear, things are normal, and if it's not, things aren't. All right, my data list that I'm looking at should be list number 3. So I got to hit the blue second button and then press number 3 to change that to L3. All right, so if I hit graph, it's going to say I messed up because I did something stupid. Good job, calculator, way to do this all. Did I do it wrong? All right, maybe it's L1. No, hang on, my calculator's waking out. See? Technical difficulties, just G messing up. Hey, what's wrong with my thing? I need to switch that. No, that should be fine. Checked all arguments entered. Press plus on menu item for catalog help. I don't want to do that. I just want it to work. All right. Anybody get theirs to work, or is it just mine being stupid? Huh? Yours? Okay, so it's just my calculator. We didn't do anything stupid. All right, so hopefully on your graph you can see what's going on. I don't know why mine's being stupid. Hang on a second. It's probably because I didn't do my minus yet. Yeah, I did not. Everything's on graph. Why are you being difficult? Yes, mine's showing as an error. So somebody got one that's working real quick just so I can bump it. Appreciate you, sir. All right. So there you go. That's what it's supposed to look like. So you go to second, y equals, and you should have L3 in your listing, and it'll show up the graph. So everybody I know sitting at home going, wait a second, Mr. D, there's some curvature in this graph. What do you mean that this is linear? These are stacked up here because we have a lot of the same number. That's all it is. So the calculator is trying to show you that you have a lot of numbers in this particular spot. All right, we got a lot of -2s and a lot of +2s. So instead, just kind of look overall, the path here is fairly linear. If the graph was more like, then we'd have an issue. So we're still linear-ish, all right? That's the main thing I wanted to show you. Please don't panic and look at it as that the graph is not linear and you can't go on any further. Remember, I told you guys this is a very casual kind of look at the test as far as making sure that it is linear. I don't have any clue why my thing's not working. That's what I get for letting somebody borrow my calculator the other day. Messed it all up. That's okay. So yeah, that's fine. I hope it works with my hypothesis test here in a minute. All right. So any questions on the graph? We find it okay. We were able to see it. So again, yes, sir. L3 is what I put in. Oh, for that one, it should be when you do it, when you do second y equals, when you switch it to it, it should be just 1 because you're on this very graph here. Cole, you put L3 on yours, right? Yeah, because you're trying to test the differences. You're not looking at the original. Again, this is what it should, I mean, this is what you should have entered in. And why mine's saying it won't work, I don't know. I know how to fix it, but it requires me retyping my list, so I'm not going to do it yet. I would hit 712, it would fix all of it. So I say somebody yesterday in another class borrowed it because we were short the calculator, and that's what I get. So might happen. Okay, so everybody's good. Everybody found the graph. So these are the 2 things you need. It's random, and because of my graph here, it is normal. Check. All right. Again, this is called granularity, where the graph has a lot of repeats in the same spot. That's okay. It's still linear. It's just the fact that we have a lot of -2s and a lot of +2s, and that's why it looks like that. So that doesn't mean it's not linear. All right, so here's our question now. Is there sufficient evidence in the differences to prove that more whales are sighted in the afternoon? That's basically the way we tested. All right, because we did morning minus afternoon. So we have to be careful about how we're going to write our hypothesis here. Think about how we subtracted. So I did anyways on my notes, morning minus afternoon. So if afternoon is more, should the differences be positive or negative? Just in general, don't look at the numbers up here, but just think about it. If I'm doing morning numbers and I'm subtracting afternoon numbers and I expect the afternoon to be bigger, okay, what kind of numbers would I get overall? I would get negative numbers, right? Because I'm subtracting a larger number from a smaller number. So that's going to help me write my hypothesis in the correct direction. That's what I'm trying to get you guys to see. So my hypothesis, alternative one, should say less than 0. I'm expecting to see a lot of negatives in the for the differences if the afternoon is in fact more advantageous for whale sighting. If I subtracted it the other way, I did afternoon minus morning, then I might flip this one. So again, depends on how you do it. Is there a right way versus the wrong way? No, it's just going to take practice to make sure you're kind of navigating these waters in a certain particular direction. All right, so our original hypothesis, again, is always that it's going to be equal to something. And then our alternative is less than, greater than, or different from. So on this one, we put a little d here because we want everybody to know that the average that I'm looking at is not the average number of whales, but the average number of differences in the number of whales. So I put a little d there to denote that this is my average difference. Same thing here. So it's not just me typing an extra letter to be fun, like it means something specific. So where this average difference is the population mean difference in whale sightings from morning minus afternoon. So notice in my description here, I write out the direction I went, morning minus afternoon. So if you flipped yours, make sure it says afternoon minus morning. All right, we used, again, UD for differences, and it equals 0 since the null should be that there is. How much difference? None. So the assumption is there is no difference. Come morning, come afternoon, everybody's going to see whales doing their thing, and it's fun. However, somebody wants me to test it, so we're going to test it. All right, again, if you subtract it as afternoon minus morning, then your alternative sign flips. So I don't know what you did on your notes. Just be aware of that, because then you would expect all of the numbers to be positive. Because again, we would be assuming that the afternoon has larger numbers, right? That's the question we're trying to ask. Is there more whales in the afternoon? So if we did afternoon minus morning, then we would expect larger numbers minus smaller numbers. So we would expect positive. All right, so let's finish the hypothesis test with the actual calculation. So in your calculator, you perform a t-test using the differences, which are in L3. So you go to your stat and you go over to your tests. Remember, you don't have to do all these formulas anymore. And the one we want is option number 2. We're just going to do a t-test, straight up t-test. You don't have to do 2 sample or anything because there's only one thing we're looking at. We're going to switch this from stats to data. All right, because we've actually typed in stuff into the calculator. Normally we leave it on stats. We type in our average, our X-bar, our standard deviation. I don't have all that this time. So I'm going to flip it to data. And then the average that I'm expecting is 0. I'm expecting there to be no difference. Go down here and look at the list and make sure this says L3. I hope mine works so it doesn't confuse you guys any further. Don't worry about frequency. And then which one are we doing? Well, since I'm doing morning minus afternoon, I'm expecting less than 0 as my number. And then I can go to calculate. Let's see if it works. It did. Miracles happen. All right, so I get negative 0.9453 as my t-score. So I'm going to write that as my calculations. Remember, these are the things we need to see on our calculation section. So I'm not requiring you to write the formula, but we need to see the t-score or the test statistic, as you will. The p-value, how many degrees of freedom you had, and your alpha. So my p-value is 0.1803. There it is right there, rounded to 4 decimals. Notice it just says p again, so don't write p equals. You'd be incorrect on that one. Don't worry about your average and your standard deviation. Don't need it. And since n is 15, my degrees of freedom is going to be 40. All right, any questions on this? You good? I was very nervous that it wasn't going to work and like you guys would be like completely like, you don't know what you're talking about. All right, so again, notice that if we subtracted the other way, afternoon minus morning, so I went from bottom to top, then my test statistic would just be a positive 0.945. It wouldn't change. I would have the same test statistic, but the p-value would be the same number. So basically what this is saying in English is you're on the other side of the graph, so the shading is to the right if you switch it versus the R shading is on the left. So your t-score matches except you're on the positive side. That's what that means in English. All right, don't forget your conclusion at the very end. So since our p-value is greater than alpha, what do? We fail to reject the null hypothesis. There is not, or there is insufficient, however you want to phrase that, evidence to suggest that more whales are sighted in the afternoon than the morning. So again, this is just a run through of tests, see what we can see. Customers want to know, if I book in the afternoon, am I going to see more blue whales? And if you've never seen the humpback and the blue whales ever before on a cruise, man, that is fun. I don't know what your guys' vacation experiences are pre-COVID. That was a blast. I got to do that in the last one time. But you want to go when the whales are active, man. You don't want to go when they're sleeping. All right, so here's just a random question to think about to kind of wrap up this unit since we've talked about all of this stuff before. How could I increase the power of this test? What if I'm worried about I made the wrong decision? Right? How do I want to make sure that my test does a better job at identifying a false hypothesis, basically? Very good. Cole said the best and most efficient way to do it, increase the sample size. So instead of looking at 15 days, we look at like 30 days. Very good. That's the most efficient, error-reducing way to increase power of a test is just increase your sample size. There is one more way, though, you can do. It's a lazier way, but it still works. What's the last other way we can do it? Anybody remember? The other way you can do it is to increase your alpha, which then increases your type 1 error risk. But if you don't have the availability of more sample size, you can just slide it over a little bit. And that may or may not have caused us to then properly identify this if we were worried about making the wrong diagnosis. But Cole said the best one, just increase that sample size. If you can go and do another 15 days, then you're even better at identifying when the whales do their job. All right, any questions? Hopefully that wasn't too scary. All right, we got just enough time to do the last example there. So you guys can get started on it. We'll read through the prompt here, and then we'll see how you do. And then that's it for the notes for this unit. And then we'll look at the learning plan and kind of see what the goal is for next week. So don't worry about this part in parentheses. Having done poorly on their math final exams in June, 6 students repeat the course in summer school to take another exam in August. Oh, lucky them. All right, so we got 2 things we're going to answer. If we consider these students to be representative of all students who might attend the summer school in other years, do the results provide evidence that the program is worthwhile? So basically, part A, we're doing a hypothesis test with 1 sample matched pair, just like we did. And in B, in conclusion, the conclusion, of course, may be incorrect. If so, which type of errors made? So we'll talk about that in a second. So basically, you've got 1 student. This is their final exam in June. This is their final exam in August. Same. So some did better, some did worse. So you got to put these babies into a list, subtract them, pick the direction you want to subtract them. Again, there's no right way or wrong way. And then we'll go through it here and figure it out. Why did my graph thing? You will have to check the graph thing. I think I figured it out. That's all it was. There's my graph on it. So the student who was using it put a tiny little squared on this Y right here, and it caused my whole complete thing to. There we go. Oh, my graph did work. That was the graph from the previous one. All right, as we go through this, I'm going to make my list 4 and 5 just for purposes of I don't want to retype this in 2 more times today. But you guys would most likely just clear your previous list and do 1, 2, and 3 the same way again, which I would suggest. That way you're not getting like list full of stuff you don't need more. But just don't panic on mine. I'm going to not want to type it in 5th and 60th. All right, if you got questions, chat, just type them into Zoom. I'm going to just wander. I'm curious what people are writing down. I'll be right back. Just out of curiosity. There's a reason why I did it that way. Not again, not that it's better or worse. You had the same thing I had. I was just curious. What's up? Very good. Yes, exactly. Because you would expect if the program works to have positive numbers. Because there should be, hopefully, doing the summer course program. Yeah, always keep that. Yeah, on this next pair one, your null on your HO, your null hypothesis is going to equal to 0. Because you assume that there is no differences until proven. You can go to your calculator.
I was just gonna watch you.
Like I say, you can subtract it either way. If you decide to do June minus August, and think about, okay, what numbers will I look for? And if the program works, you would hopefully see negative numbers if you did June minus August. So then your alternative should be less than. And if you did it August minus June, then you should have an alternative positive because you would expect to see positive. And the hope is this program is working. Otherwise, these kids and teachers are wasting their time. That's summer school. All right, take about 2 more minutes, then we'll go over the rest of this and we'll see where you guys ended up with as far as your decision-making process. What was your conclusion? Excuse me. All right, let's have a look at what we did. So for this particular problem, all that's up here is kind of a hot mess. I'm going to walk you through it. It's just a big, so we'll go through it step by step here. So the name of this test is a one sample t-test match pairs. Again, unless you want to write out that entire formula that we've been talking about in the past and doing all those steps, you need to write the name up here so they know what you're doing. So you have two assumptions. You need to make sure you verify that you have a simple random sample of summer school students. Check. I mean, it didn't say it in there, but we wouldn't be doing the problem. And then number three, we got to say normal because the probability plot is approximately linear. So for this one, I chose to do August minus June because I assumed there would be some sort of increase, and I'm looking to see if that's the case. So for my L6 here, excuse me, I'm going to do L4 minus, I'm sorry, wrong way, L5 minus L4. All right, so these are my June, these are my August. So if everything goes according to plan, there should be enough difference there to say, hey, this program actually makes a difference. So now I can then go to the stat plots, go into here, and then change this to L6. So second, 6. And we can look at the graph, and then again, hit zoom number 9. Boom, there's my graph, there's my picture. This is approximately linear. And this is good enough for government work, as they say. So we're good. Our assumptions are met. So my hypothesis was that the average is equal to 0 for the null. That's always going to be the case for these matched pair ones. And that the alternative, we're looking for positive numbers. Again, I'm expecting there to be an increase if we can see a difference. So all the August minus June numbers should give me enough of an increase. And then we define what the difference is between these two. So we're going to say where the average difference is the population mean difference in exam score for summer school students. And again, stipulate, or I don't know, that's the word, state that your subtraction went August minus June. Like, let people know this is the direction I went. So make sure that's in your little definition here. Again, if we had switched the other way, not saying that this is wrong, but if you did L4 minus L5, you did June minus August, then you would just need to flip your alternative the other way around. Everything else is fine. You just need to flip that. And then you would have to change this here of June minus August. So it's not going to change your final answer. You just need to pick a direction and go with it. And there's not a right way, just go with whatever feels right. All right, calculations time. So again, we go back to, this is for the people that need to see the calculator steps. Go to stat, go over to tests, and we're doing option number 2 on these. We're doing a t-test, straight up, one sample. All right, again, we're entering data into our t-test. We're not doing stats this time. We expect the null to be 0, but I just have to change my list from 3 to 6. That's pretty much it. And then don't forget to switch down here that we're now looking for greater than 0 as our difference. Questions on that? We okay there? All right. Calculator is great, but if you flip it or do something goofy, you won't know because we're relying on it. All right, so you type everything in, and I get 1.7541 for my t-score. So there it is right there. My degrees of freedom is going to be 5 because I tested 6 kiddos. My p-value is 0.0699 and didn't say, so alpha is just 0.05. You can draw the graph if you want to, not required. But this is the side of the graph we're on. If you flipped it and you did June minus August and you got a bunch of negative numbers, then your graph's on this side. All right, so based on my p-value being just slightly bigger than my alpha, we're going to fail to reject the null. There's still not enough sufficient evidence to say that the program helps improve test scores between June and August. Sorry, kiddos. Welcome to summer school. Didn't make you smarter. All right, last question real quick, just to make sure we got this whole unit wrapped up. If we were failing to reject the HO, which was our decision, what would be our error, type 1 or type 2? We decided to fail to reject DHL, type 2. So this is our decision. It's possible we made a type 2 error. So just keep that in mind. We're not saying we did, but it's possible. Exactly right. Exactly right. So maybe there is a difference there. Maybe these kids are actually getting smarter over summer school and we made the wrong decision. So again, if we don't want to live with this type of error, ways to decrease beta would be, Cole's answer is again so relevant, increase that sample size, quit testing just 6 kids, go test like 30 kids. And then the other things you can do to increase beta is have obviously a bigger difference between your original and alternative hypothesis. And then obviously you can always move alpha up, but then you increase a type 1 error where maybe you reject it and it's still true. And then you're telling everybody, hey, go to this summer school program. It makes your kids a genius. And it's not. All sorts of fun things in life, and you guys can kind of understand stats. So as far as like crazy stuff goes in this class outside of like chi-squared, we're pretty much wrapping up this year. We got just a little bit of notes left for unit 8, but not much. So let's look at the learning plan real quick, and then we'll be good to go for the day. Anybody still writing? Close that baby down. All right, so let's look at the learning plan, just so you guys kind of know what's what for the rest of the week coming up here. It's Friday, man. Be happy. All right, so learning plan for Monday through the rest of whatever. So Monday is the 29th and 30th is the Tuesday. So if you haven't completed your 2 proportions with means homework, your 2 means regular homework, and your matched pairs homework that we just started, it'll be the day before your quiz. So looking at the setup here, it's a practice quiz, so it's not going to be that big a deal. So I'm going to say we'll do our practice quiz just on Monday, because I'd rather have Tuesday as a day to review. That way, Wednesday and Thursday, when we do our test, you guys have that extra day. Versus if we do the quiz on Tuesday, then it's like quiz, test, test. So that's going to be the plan. It's just a practice quiz on Monday, so it's not going to like affect your grade. It'll just give you an idea of where you're at with this stuff, and then you'll have all day Tuesday asking for help. So I think that sounds like a good plan. So try to get your homework done by Sunday night, so that gives you the rest of the day, Saturday and Sunday. So I'll change the due dates in there to make sure they reflect that. Practice quiz will be on Monday. It'll grade itself because it's in Canvas this time. We'll go over any questions you guys have or whatever on Tuesday, and then our test will be on Wednesday and Thursday next week. So you'll have until basically Wednesday or Thursday next week. I'll probably just make it Thursday to help you guys out, to get your mixed review in at the back of that packet and Unit 7 Albert I.O. So just pay attention to the things that you got to turn in. There's reminders in here to do so. So you don't have, you notice FRQs, yay, no FRQs. And you don't have textbook, yay, no textbook. So at least I don't see any on it. So all you have to do, yeah, it's just stuff from the homework packet. So you basically just got the homework packet and then the Albert I.O. because it is going to be a multiple choice section in, and I'm sure the questions will be just as fun as they were last time. So what I was thinking about doing, you guys tell me if you like this or not, you don't have to decide today. I was thinking about recording me going through the multiple choice for you, just as a way to review it after, just to help out with that Albert I.O. stuff, because I think the solutions don't always make sense, and maybe explain it from our perspective in class to see if that helps you guys out with your multiple choice reviews. I'll try to do that sometime between now and Monday, and then publish up there just like Mr. G does Albert I.O. And you can watch me make mistakes too. All right, I'll try it out. If you guys, I see people going, that would be helpful. All right, so I'll try to do it. I'll ask the other classes too. Because we used to do afternoon, late night, whatever, like before the test tutoring. But they don't want me doing that this year because of all the weird at-home learning situation stuff. So I haven't been able to do like that in the past. I used to do like an hour, hour and a half long session, like 7:30 on the night before the test and people like that. So instead of that, I'll just record myself doing the Albert I.O. because that was what 90% of the people wanted help with when we had those reviews. Anyways, have a good rest of your Friday, guys. Enjoy your weekend. If you got questions, bring them on Monday. It is just a practice quiz, so don't stress it. We'll come in. We'll just see how you do. You bet, guys. Have a good weekend. Weird week. Have a good one. Anytime, Mr. Rowe. Have a good weekend, sir. You girls are going to the soccer thing, right? Yeah, have fun. Will you be here on Monday or no?
Yeah, because our class is so early that I
Because Delaney was like, I may not be back on Monday.
yeah.
Nah, you don't have to. You don't have to take it. Morning, Mr. Connor, how's it going, sir?
Pretty well.
It's Friday, man. That's good. Made it. One more week in the books. What's up, Jay? You got a question before I sign off, man?
Yes, I do.
Ask away,
Um,
senor.